Good morning, ma. Next. Ma, in this third unit, already we complete the first topic, ma. Here, next topic is the conditional execution and iterations. Next topic is the first topic is expressions and statements is completed, ma. Next topic is the conditional execution and iteration, ma. Here this is the second topic in our third unit. First, here conditional execution. Here in this conditional execution of different statements can be specified in of the most of the languages. Here we have conditional executions. Here for example, if statement, if else statement, if else statements, nested if else statements. There are the conditional execution statements. Here some of the languages we are conditional execution statements by different syntaxes. Here in this conditional execution of different statements can be specified in most languages by the if statement. By the if statement languages, different several important syntactic details. Means here have to know about the syntax and semantics of the conditional executions. For example, in C language we have if statement, if conditional statement. We have to know about that syntax and what is the meaning, how we work for the if statement. That's like we have to know about the syntax and semantics of the particular conditional execution statements. Here that is the meaning of this, ma. Here conditional execution of different statements. Here different statements means we have if statement, if else, next nested if else, like that. Here it is specified in most of the languages by the if statement languages in several important syntactic details. Syntactic means syntax. Next how we construct, how we work, like that. Means semantic means how they are like, means how they are like. That is called here semantic, means or meaning. Semantics are meaning here. Here next point is syntactic details are not irrelevant the syntactic appearance of a program. It contributes to be readability, easy of change, and ultimately to be reliability. Here by using the syntactic, how to easy reading and easy to change and easy to reliability, that are the syntactic details here. For example, we are having some of the programming languages, C, C++, Java, ALGOL, Pascal, likewise. Here this example is this example related to ALGOL 60 language. ALGOL 60 language. Here let us start with this example here. Here if the statement as originally provided by the ALGOL 60. Here ALGOL 60. ALGOL 60 means here 60 means version here. In this ALGOL language we are having two forms. These are two forms are possible, ma. Two forms are possible. Here these are the examples. If I equal to 0, then I equal to j. If I equal to 0, then I equal to j. Else begin, j equal to j minus 1, end. Here in this language, in ALGOL 60 language, here we have to write like this, j colon equal to. In C language you have to write assignment operator only equal, but in ALGOL 60 language you have to write like this, colon equal to, colon equal to. This is the assignment operator we are using in the ALGOL here. You have to assign that value I equal to j, else begin j equal to j minus 1 end, j minus 1 end. This is one of the possible. Next, this is the another possible ma. If I equal to 0, then I equal to j, I equal to I plus 1, I equal to I plus 1. These are the two following examples. Two forms are possible here. Likewise here in the first case, in this is the first form, this is the second form here. In this first case, no alternative is specified for the case I equal to 0. In this first case, no alternative is specified for the case I equal to 0, and nothing happens here if I equal to 0. Here there are two alternatives are present here. What are the two alternatives means? Here, since the case here where I equal to 0 it is cleared by sequence, it must be a compound statement. It must be a compound statement by bracketing begin with end, begin and end. Here begin and end. This program, in this program, here in this case first else begin, next you have to get the end, else begin, next end, program end. You have to write like this. In C language he write the curly brackets open, curly brackets close. Here you have to write likewise, begin end. Here this selection statement of ALGOL 60, it is well known of ambiguity. Ambiguity means here ambiguity, all our conditions are satisfied, all conditions are true, that is called the ambiguity here. Same. Next, for example, we have like this ma, if x greater than, this is the selection statement of ALGOL 60. If x greater than 0, for example, if x greater than 0, then if x less than 10, then x less than 10, then x equal to 0, else x equal to 1000, x equal to 1000. Here if x greater than 0, then if x less than 10, then x equal to 0, else x equal to 1000. Here it is unclear if the else alternative is part of the innermost conditional here. Here it is unclear if the else part, else alternative is a part of the innermost conditional if x less than 10, or the outermost conditional is if x greater than 0. If x greater than 0 is the outermost conditional, here x less than 10 is the innermost conditional. Here the execution of the above statements x equal to some 15, or give the x equal to, give the value is 15, 15 less than 10, condition if 15 greater than 0, condition true, 15 next, if 15 less than 10, condition false. We go for else statement. Here else statement, here it requires the unconditional statement and then branch if the statement here. Here then the above statement can be replaced like this here. Here I have to eliminate ambiguity. You have to eliminate ambiguity. You have to write the in this ALGOL 60 requires an unconditional statement in the branch of an if statement. Here in this, if x greater than 0, then begin if x less than 10, then x equal to 0, else x equal to 1000, end. If x greater than 0, then begin if x less than 10, then x equal to 0, else x equal to 1000. Here next or if x greater than 0, then begin if x less than 10, then x equal to 0, and else x equal to 1000. Have to write this above statement must be replaced by either these two, either these are that. Next here the same problem it is solved in the C language. Here this is the in ALGOL 60, means you have to eliminate the ambiguity in ALGOL 60. It requires unconditional statement here. Here the above statement is replaced by either this or that. If x is greater than 0, then begin. If x less than 10, then x equal to 0, else x equal to 1000, end. Next, if x greater than 0, then begin. If x less than 10, then x equal to 0, and else x equal to 1000. Here next, the same problem is solved in C language and Pascal. The same problem is solved in C and Pascal language. It is automatically matching an else branch. It is automatically matching an else branch to the closest conditional without an else. Here the same problem, what is the same problem is to eliminate the ambiguity here. That is a problem here. It is solved in C and Pascal by automatically matching the an else branch to the closest conditional without an else. Here, even though the rule removes the ambiguity. Here, however, nested if statements are difficult to read, especially if the program is written without careful indentation. Indentation means, for example, here if x greater than 0, if x greater than 0, then in next line you have to write under not under if. You have to give the space. After that you have to write then. Okay, that is called the here indentation. Means in looping statements, in conditional statements, in Pascal language we are having the indentation. That means to give space. For example, give the for loop for I equal to 0, I less than n on the time. Here we before under for you have no need to write here. You have to give the space. After that you have to write. That is indentation. Next here syntactic means to avoid the problem in ALGOL 60. To avoid the problem is adopted by the ALGOL 68. To avoid the problem is adopted by the ALGOL 68 here, and ALGOL 68 ADA language and Modulo 2 language. These are used the special keyword. Means here you have to enclosing the bracket here, and if the first statement it is in case of ALGOL 68, and if the case of ADA and end it is in the case of Modulo 2, these are would be Modulo 2 coded like this. Here in this, to avoid the problem in adopted by ALGOL 68, here ADA language and Modulo 2 language, which are used the special keyword as an enclosing final bracket of the if statement, here if statement in the case of the ALGOL 68 and in the case of the ADA. Next end in the Modulo 2. Here the above example it would be coded in Modulo 2. Next, Next in modulo 2, here we have some code ma. If I equal to 0, then I equal to j. Next else I equal to I plus 1, j equal to j minus 1, and if I equal to 0, then I equal to j, else I equal to I plus 1, j equal to j plus 1. J plus 1. If I equal to 0, then I equal to j, else I equal to I plus 1 and j equal to j minus 1. Here you have to give the end. You have to give the end here. Next, if x greater than 0, then if x less than 10, then x equal to 0, else x equal to 1000, end. How to give the begin and end in some of the languages, but in C language no need to give the begin and end. You have to give the brackets, bracket open, bracket close, like that. But here in these languages you have to write like this conditions. If some condition, next then if some condition, then you have to begin, else begin. So how to give some condition, after that you have to close. How to close means you give the end function, end. Next, here it is depending on the desired interpretation ma. It is desired on the interpretation. Next, you have to choose the more alternatives. You have to choose the more alternatives here. And to choose the more alternatives. What are the more alternatives means? If A, then else S1, else if B, then S2, else if C, then S3, else S4, and like this. You have to choose more than one alternatives. If then else statements. If then else statements. These are the constructions of such as we are having the if A, then else S1, else. Next we give the if B, then S2, next else. Next B, if C, then S3, else S4, end. Next, this is the syntactic variation that avoids this problem. Is adopted by ALGOL 68, ADA and Modulo 2. This is use of the special keyword here. How to here's what is the special keyword means. Here in ALGOL 68 language we use the F5. Use the F5 means how we are using the if statement, IFF in ALGOL 60. Next C language, ADA, Modulo 2. But here if the in ALGOL 68 we have to use F5 instead of if. We are using F5. It is in the case of ALGOL 68, and if in the case of ADA, and in the case of Modulo 2. These are the examples which are coded in the Modulo 2. Here if I equal to 0, then I equal to j. Next else I equal to I plus 1, j equal to j minus 1, and next and if x greater than 0, then if x less than 10, then x equal to 0, else x equal to 1000, end. Next or next if x greater than 0, then if x less than 10, then x equal to 0, and else x equal to 1000. Have to depending on the desired interpretation. These are designing are depending on the desired interpretation. Here next you have to choose the more than two alternatives by using only if then else statements. If then else statements. Here this is the likewise. Here if A, then S1, else if B, then S2, else if C, then S3, else S4, and here you have to and A if condition is open, begin, next end statement, next if B condition is open, next end statement, next if C condition open, end statement. Likewise you have to write these more than two alternatives using the if then else statements like this. Here next in ALGOR 68 language. Next to solve this, here to solve this syntactic inconvenience, means this is the inconvenient, that's why we have to use the modular 2 as an else, modular 2 as an else if construct, it also serves as the end bracket for the previous if. Here for example you take here if A, then else 1, here if A, then S1, else if B, next then S2, else if C, next then S3, else S4. Likewise you have to write the in modular 2 else if construct like this. Here to have to solve the syntactic inconvenience, we are having some of the inconvenient, that's why we are using like this. This is the for the above code you have to write like this. If A, then S1, else if B, then S2, next else if C, then S3, else S4, and likewise. Here in C language, in ALGOR 68 language and ADA, it provide the some of the similar abbreviations. Here similar abbreviations. Here most languages can provide the ad hoc construct to express the multiple choice selection. Here for example we take the C++ provides the switch construct. C++ provides the switch construct. In that switch construct we are in C language, we used the switch operator. For that switch operator we have multiple options we are having in the switch operator. Here these languages also provide the ad hoc construct here to express the multiple choice selection. Here in this multiple choice selection we are having here switch operator case plus. This is in C++ provides the switch construct. Here switch operator give the case plus, next result equal to operand 1 plus operand 2. Operand 1 plus operand 2 means you have to give the break. Next in case plus operand 1 plus operand 2 break. Next case asterisk means we give the operand 1 star operand 2 break. Next minus operand 1 minus operand 2 break. Case divide by means operand by operand 2 you have to break. Next you have to give the default. In that break do nothing. Here each branch it is labeled by one constant values. Here based on these value of the switch expression, the branch it is labeled by the same value is selected. Here if the value of the switch expression does not match any of the labels here, if the value of the switch expression does not match any of the labels here. Here it is the optional default. It is the optional default. Default branch is executed. Default branch is executed. Here, if the default branch is not present here, no action takes place. No action takes place here. Here, the order in which the branches appear in the text is immaterial here. If the above example you are having the break statement, it is used to terminate each branch. In the above example, you have to explicit the explicit break statement, it is used to terminate each branch here. Here, otherwise execution would fall into the next branch. Otherwise would fall into the next branch. Otherwise execution would fall into the next branch here. Here the some example, the same example may be written in ADA language. May be written in ADA language. How we write in the ADA language means we are having case operator here like this. Case operator is means we are using the switch operator in C language, C++ language, like that. We have to select the multiple options or multiple selection. On that time we are used in C language switch operator, switch case. Here in ADA language, how we write this? In this is the example in ADA language. Here case operator is when plus result equal to operand 1 plus operand 2. When asterisk means result equal to operand 1 star operand 2. Next, when minus result equal to operand 1 minus operand 2. Next, when slash means here we give the result equal to operand 1 by operand 2. When others equal to null, here end case means in ADA language you have to write this case operator like this. This is the syntax in ADA language. Already we know about the in C language switch case operator, switch case in C, already we know about in C language. Next, in C++ here, next point is in C++ either or both of the expression in a for loop can be omitted here. Here it is used to write an endless loop. It is also called as it is used to write an endless endless loop as like this, for colon bracket open, so on, number of statements here. Here in C++ we are using the both of the expressions in a for loop can be omitted here. It is used to write an endless loop. Here for condition, initialization, condition, next increment or decrement. Here we use the initialization semicolon, next condition semicolon. That is the syntax for that in C language. In C++ like this, for semicolon same meaning here. Condition, next increment or decrement, next bracket open, next bracket close. Next these next point is while loops are also named after a common statement it provided by the language of ALGOL family. Here while loops it also named after a common statement. It is provided by the languages of the ALGOL family. Here a while loop describes any number of iteration of the loop body. Here this while loops it is also named after a common statement. It is provided by the language of the ALGOL family. ALGOL family means you are having some of the versions here, ALGOL 60, ALGOL 68, ALGOL 90, like that. That's why we call the here ALGOL family. Here in this while loop describes any number of iterations of the loop body including 0. They have the following general form here. While condition do statement. Here. Next, For example, we take the in Pascal fragment. For example, we take the Pascal fragment. Here in this Pascal fragment, it describes the evaluation of the GCD. Here in Pascal fragment describes the evaluation of the GCD. GCD means greatest common divisor of two variables A and B by using the Euclid algorithm. Have to evaluate the greatest common divisor. For example, here while A or B do begin, here, if A greater than B, then A equal to A minus B. Here, while A or B do begin, if A greater than B, then A equal to A minus B, else B equal to B minus A, and here this end condition A or B, it is evaluated before executing the body of the loop. The end. Here the end condition, A or B, it is evaluated before executing the body of the loop. Next point is the loop is existed if A is equal to B. In such a case, it is a greatest common divisor. Next, therefore, the program works also when it is executed in the special case. Therefore, the program works also when it is executed in the special case. Here, where the initial values of the two variables are equal. Here, this is the end condition A or B, it is evaluated before executing the body of the loop. Here the loop is exited if A is equal to B, since in such a case A is the greatest common divisor. Next, therefore, the program works also when it is executed in the special case where the initial values of the two variables are equal. Here this is about the conditional execution and conditional iterations. Here what we learn in this topic means, here in we are having number of different number of languages in C language, C++, ALGOL, Pascal, ADA, Modularity. Likewise, here how we construct, how we syntax and how we write that, and what is the meaning of that syntax, what is semantic of that syntax for conditional execution statements and looping statements. Likewise, we know in this topic in Pascal language, how we write the while loop, in ADA language how we write the for loop. Next, in C language how we write the while loop and how we work the while loop and how we work the for loop in C language. Likewise, in this topic. Next topic is routines. Up to this, in third unit we completed two topics. In last class one topic is completed. In this class second topic is the conditional execution and iterations, means in different languages how we run the conditional executions and how we write the iterations in different languages. We have to write the syntax or example programs in different types of languages. That is the topic in second topic. Here. Next topic is the routines. 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 Here, this is the topic. Routines are the program decomposition mechanism. Here we have some programs. In that programs, it is a program decomposition mechanisms. Here, which allows the programs to be broken into several units. Here means you are having some big program or small program like that, and program it allows, means program routines are the it is one of the mechanism. It allows the programs to broken into several units, likewise functions like that. Functions, for example, functions, in that functions, one big program, we are having one big program, means in that for example you take addition, subtraction, multiplication, division. You have to write one program only. On the time you have to divide, divide addition, subtraction, multiplication, division functions. Likewise here routines are a program decomposition mechanism. It allows programs to broken into several units. Here this routine calls are control structures, and it is flow of execution, flow of control among the program units. Here in this routine calls are the control structures. It governs the flow of control among the program units, Here the relationships among routines, defined by calls are asymmetric. Here the relationships among routines defined by the calls are asymmetric, means here the calls transfer control to the callee, means called function control transfer to the calling function. It is named by naming it explicitly. Here the callee transfers control back to the caller without naming it the unit to which control is transferred when a routine R. Here the callee, we are having called function, calling function. Two functions we are having in C language. Here in this routines we are having caller transfers controls the callee by naming it explicitly here. Here the callee transfers control back to the caller without naming it. That unit to control is transferred when a routine R. In this routine only transferred to the, you have to control is transferred to the from callee to caller. It terminates when are executing immediately before R. Here routines are used to define abstract operations. Routines are used to define abstract operations. What are the here abstract operations here means here next, most languages distinguish between the two kinds of routines here. Most languages distinguish between the two kinds of routines here. What are the two kinds of routines means here? Procedures and functions. Procedures means does not return a value. It does not return a value. It is an abstract command which is called to cause some desired state change. This procedure means in C programming language we are using that name is called, routines name is called functions. But in procedures means here ADA language and Pascal language, ALGOR language, we are using functions like procedures. You have to give the procedures. Procedure does not return a value. It is an abstract command which is called to cause some desired state change here. The state may change because the value of some parameters. Functions we are having two parameters, formal parameters and actual parameters. In this the state may change, means I have to pass the actual to formal and formal to actual parameters. Because the value of some parameters is transmitted to the procedure, some gets modified here. Some non-local variables are updated by the procedure, means here example reading or writing like that in that procedures. Next, function means it corresponds to the mathematical counterpart. Here in this its activation is supposed to return a value here. It depends on the value of the transmitted parameters. We have to give the parameters formal to actual to formal parameters. Next, Next, another point is here, for example, you take Pascal language. It provides both procedures and functions. It allows the formal parameters either by value or by reference. We are having value means by value or by reference. Formal parameters by value and formal parameters by reference here. Here the Pascal provides both procedures and functions here. It allows formal parameters to be either by value or reference. Here it also allows the procedures and functions to be parameters. And this is the example of this procedure. Example, variable x in t. Next, y q makes give the function procedure function of z r, give the r is integer. Here in this example here, x is by reference, small x is by reference parameter, small x is by reference parameter of type t, x is by reference parameter by t, type t. Here y is the by value parameter of by type t, by type q. Here f is the function parameter. It takes one value parameter, one by value parameter x. Z of type r, it returns an integer. Here next language is the ADA provides the both procedures and functions. Pascal also provides the both procedures and functions. Likewise, ADA provides the both procedures and functions here. Here in this ADA parameter passing mode, it is specified in the header of an ADA. It is either in out or in out. Next, in out. Here if the mode is not specified like this, it is assumed by default, by default here. Here a formal in parameter, it is a constant. It only permits reading of the value of the corresponding actual parameter, Next, in C language, all routines are functional. For example, you take here void. This is the call by reference. Void procedure will give the procedure. Here int star x, int star y. Here return type is void. Return type is means no value is written here. Void is the no value is written. Here parameters can only pass by value here. Here by using the parameters int star x, int y means you have to give the, this is the pointer value. In this star x equal to star x plus y. Here you have to increment the object referenced by x by the value of y. If we call the proc as follows like this: proc of ampersand a comma ampersand b. That means here ampersand a means the address of a here. Here x is initialized to point to a, and routines we are having routines, a routine increment by the value of b here. Here in this C++ language, it use directly have to specify the call by reference. Here in this C++ language, this is the example. Void proc int x comma int y. Int ampersand x means we have to give the address value of the x, int y. Here x equal to x plus y. You have to give the procedure a comma b. Means here no address operator is needed in the call. This is the C++ language example. Next is the while in this Pascal only allows the routines to be passed as the parameters. In C++ and ADA get closer to the routines, and in they provide pointers to routines. Here, and it allows pointers to be the bounded automatically to different routines at the runtime here. Here next we are having some of the style issues. Style issues. In this style issues, we are having side effects and aliasing here. Side effects and aliasing here. Here in this style issues, here communication can be established through non-local variables here. Non-local variables here. If the set of non-local variables for the user for this purpose is large. Here for example, you take if unit u1 calls u2 and u2 it is modified the non-local variable. In this non-local variable, x is used for communication between u3 and u4 here, and this invocation of u2 produces an undesired side effect. Undesired side effect here. Here next. Next, these are errors are difficult to find and remove. That's why you have to be because the symptoms these are not easily traced to the cause of the error. We are having type error. We are getting the some of the programs for type error. This can lead to some of this problem here. That's why it is another difficulty. Here side effects are also used in passing parameters by reference. Another, in such a case, side effect it is used to modify the actual parameter. Here the programmer must be careful in not produce the undesired side effects on actual parameters. Here the same problem arises with the call by name. Call by name. The same problem arises with call by name. Here in this languages it distinguishes between the functions and procedures here. Here have to suggest the programming style in which the use of the side effects is restricted here. Some of the programming languages side effects are also acceptable programming practice for the procedures here. Here this should be a way of procedure send results back to the caller here. Here in these side effects, here we are having function subprograms. Here in this function subprograms have to invoked by the some writing the subprogram like this v equal to x plus f of x comma y plus z. Here this recognition side effects on parameters here these are undesirable for the function affected the design of ADA language. It allows only in the formal parameters for functions. Formal parameters for functions. These about the routines. These about the routines.